Okay. We have this system and we want to eliminate variables. Now we notice it'd be easy to eliminate Y, be easy to eliminate Z. Okay. So it's fairly natural to go ahead and do that. So this is equation 1, equation 2, equation 3. Now some people chose to eliminate Z and multiplied this by 10 and this by 5. Okay, that's overkill, but it's okay. It still would lead to the right solution. If I just multiply this by 2 and the 5 and the negative 10 are going to line up. Okay, so usually you want to take the least common multiple, but if you take any common multiple, it's going to work. Okay, but you want to try to get easier numbers. So we do, let's do 2 times equation 1, then equation 2, and equation 3. So we get 6x minus 8y minus 10z equals negative 12. And then I'm going to do equation 2, which is 2x plus 8y minus 10z, that should have been a plus, equals 16. And I've put negative 12 here. I should have negative 24 because we got a double back. Okay. When I do that and add the 2 equations, I get 8x equals negative 8. Now I think some people got x equals 5. That would come about if you didn't have the right signs on the 24 and the 16, you would get 40. 48 divided by 40 gives you 40 divided by 8 gives you 5. So now that won't ordinarily happen, but it happened in this case. So now that we have a solution for x, we can plug that into any 2 equations. Okay. Now we use the first 2 equations to get this. We need 2 different equations. But we're going to have to use one of the first 2 because there's only 3 equations, right? So we're going to have to pair this one up with one of these, and it doesn't really matter which. Now I've jotted this down for what I was talking about earlier, but I'll do it again. So now substitute x equals negative 1 in the second and the third of the original equations. So the second is going to give us 2 times negative 1 plus 8y minus 10z equals 16. And get it right. The third equation is negative 1 plus 2y plus 3z equals negative 2. So now we have a system of 2 equations. It looks a little weird because we got these numbers over here, but we get rid of those and put all the constant numbers Well, we subtract off all the constant numbers, and we get equation one, which would be 8y minus 10z equals 18. Because we have -2 here, so we add 2 to both sides. Adding 2 to this side gets rid of the -2, and adding 2 to this side gives us 18. And I'm not going to write that step out, but that's what we did. And similar here, we just add 1 to both sides, and we get 2y plus 3z equals -1. Now we want to solve this system. So we write equation 1 and -4 times equation 2. That will eliminate y. Okay. So we're going to have 8y minus 10z equals 18, and -8y minus 6z equals it's not 16. Well, yeah, -22z equals 22. The z equals 22 over -22, which is -1. And now, since I'm running short on space, I'll use arrow. We plug in z equals -1 into one of these two equations. And we get 8y minus 10 times -1 equals 10. So that's 8y plus 10 equals 18. And we get y equals 1. We subtract the 10 from both sides, we get 8 on this side, divide both sides by 8. So now we have our solution. Okay. So our solution is x equals -1, y equals -1, z equals. So I've seen most of the right steps. These steps were labeled correctly. Just got to be careful about the arithmetic. Check everything as we go. Now let's do the augmented matrix. What steps? Okay. Now this is the augmented matrix. It just consists of the coefficients 3, -4, 5, -12. 3, -4, 5, -12. With a little dotted line here, remind us this is on the other side of an equal sign. And well, we do the same for the second and third equation. We write down the coefficients and we double check it because we don't want to make a clerical error here. It's usually going to contrive these equations so that they have an integer solution. Now, in the real world, you can never expect to see integer solutions. Okay, and you have to do the fractions. But right now, we're just trying to get this method down. And that when you encounter it later, in a later course, maybe with fractions and so forth, you can deal with it there. Okay, now the first thing I'm going to do is, well, what's my goal? Okay. You get a 1 in the first row. I actually have two choices, actually three choices. I could subtract the second row from the first and replace the first, right? I could subtract 3 times the third row or 2 times the third row from the first and replace the first. But what I'm going to do is avoid any arithmetic at all on this first step. And I'm just going to switch the first and third. Line 1 becomes line 3. And line 2, row 2 stays the way it is. So if line 3 becomes row 3 becomes row 1, I get 1, 2, 3. Stays the same. It's 2, 8, negative 10, 16. Row 1 becomes row 3, so row 1 comes down here. That's going to be 3, negative 4, 5, negative 12. So I got my 1. Okay. Once I have 1 here, I can get my zeros here very easily. Okay. Write down row 1. I'm never going to change. Well, I'm not going to change row 1 until I've got 1s here, here, and here, and zeros down. We'll see how that works. So row 1, I'm just going to write down. Row 2 is going to become row 2 minus 2 times row 1. Now, as I recommend, most people are going to want to calculate this out. Be sure you calculate it miles away from wherever you're writing the system, okay? Because you want to see how the system evolves in a column. All right. So if I do the number in row 2 minus 2 times the number in row 1, and you can write this out if you like. 2 minus 2 times 1 gives us 0. And 8 minus 2 times 2, that's 8 minus 4, that gives us 4. Negative 10, sorry. Yeah, negative 10 minus 2 times 3. 2 times 3 is 6. Negative 10 minus 6 is negative 16. And then 2 times negative 2 is negative 4. 16 and negative 4 gives us 12. Now, just to show you, I'm not going to write out step every time, just to validate this. Here's row 1. Here's 2 times row 2. Negative 2 times row 2. Row 1 is 1, 2, 3, negative 2. Row 2 is 2. Sorry. Writing things down. Let's do negative 2 times row 1 added to row 2. Well, row 2 minus 2 times Start with row 2, which is 2, 8, -10, 16. Minus 2 times row 1 is minus 2 times 1, which is minus 2, minus 2 times 2, which is minus 4, minus 2 times 3, which is minus 6, and minus 2 times -2, which is plus 4. And I made a mistake here when I did this. 16 minus 2 times this row would be 20. So I probably should have written it. Now when I add, I'm going to get 0, 4, -16, and 20, which is what I now have here. So by writing this out, I caught myself in an error. Okay. Now, if you didn't do that intentionally to illustrate anything, I just really made that error. That shows me I'd better be careful. Okay. So I'm going to do the next step. I want 0 here. Well, if I subtract 3 times row 1 from row 3, so I write row 3 and minus 3 times row 3 is 3, -4, 5, -12. One is -3, -6, -9, plus 6. I add these, I get 0, -10, -4, -6. And that works. Okay. I'm going to erase these. And I'm going to now get the next step. I've got the 1 here and I've got zeros below it, right? Now what I want to do is I want to get a 1 here and a 0 below. Okay. I'm not going to bother getting the 0 above just now, and you'll see why not in a minute. Okay. So how am I going to get a 1 here? Right now I've got a 4. Maybe I better divide by 4, right? So my next row is going to be, or my next matrix is going to be row 1, 2 divided by 4, and row 3. Now I'm going to have 1, 0, 0 here, and then I'm going to have a 2, 3, -2. I divide this row by 4. I'm going to risk not writing out the whole process. And just write a 1 here, -4 here, 5 here. 4 divided by 4 is 1. -16 divided by 4 is -4. 20 divided by 4 is 5. Then I'll have my -10, my -4, and my -6. Next, I want a 0 here. I could get a 0 up here as well. but there's gonna be an easy place. So I'm gonna work to get the ones in the diagonal and the zeros below the diagonal. One will stay the way it is. Is gonna stay the way it is. And row 3, then I'm gonna have to take 10 times row 2 and add it to row 3. Let's scratch it out down here. I'm gonna write row 3, which is -10. Well, it's 0. 0, -10, -4, and -6. And 10 times row 2 is going to be 0, 10, -40, and 50. When I add these, I get -44 this side, and I get +44 on this side. That gives me them 0, 0, -44. Four. So now I've got my ones here, and I've got my 3 zeros down here. Next thing I want to do is just divide row 3, -44. So I have 1, 2, 3, -2, 0, 1, -4, 5, 0, 0, 1, 1. Okay. Now this tells me what? This tells me that z equals 1, right? Okay. At this stage, I could write down the 3 equations that I get here. This is one option. Equations now and solve. First equation would be x plus 2y plus 3z equals -2. Y minus 4z equals 5. Z equals 1. Now it's going to be a little messy. It'd be better if I was working in columns, but try to keep it simple. I take z equals 1 and I plug it in to the equation right above it. The equation I get is y minus 4 times 1 equals 5, which is just y minus 4 equals 5. They're wrong because I get y equals 9. There's a mistake in here somewhere. Ah, when I divide 44 by -44, I get -1, don't I? Okay. I'm being more careless than usual this morning. So we get z equals -1. So that would be y minus 4 times -1 equals 5. So we get y plus 4 equals 5. And then we subtract 4 from both sides. We get y equals 1. Okay, now take our y equals 1, plug it into the second equation. Our z equals -1. Sorry, this is the first equation. Okay. In other words, we got values of y and z, we plug them in here, so we're going to be able to easily find x. And that's going to lead us to the equation x plus 2y, that's going to be 2 times 1. And then 3z will be 3 times -1. And that's equal to -2. Well, you get 2 here and you get -3 here, which means you're going to get -1, and you add that to both sides. And very quickly, you get x equals 1. And we see that the solution agrees with the solution we got after making several mistakes in the original set. Okay. Now just to complete this thing. Triangular form. Two, 3, -2, 0, 1, -4, 5, 0, 0. Well, got to do -3 times row 3. Now I am just going to point here. 3 times row 3 is going to give us a 3 and a -3. So, sorry, -3 times row 3 will give us a -3 and a +3. -3 added to 3 gives us 0. So that's going to give us 1, 2, 2. Then our second row is going to be the second row 4 times the third. If we multiply 4 times the third row, we're going to get 4, -4. Adding the 4 to the -4 in row 2, we're going to get this, and then adding -4 to the 5, we're going to get 1. So we've used this 1 to wipe out the -4 and the 3 above it. And now we've got a solution for y. And I keep not wanting to write my negative sign here. Okay. We only have one step left. Now take the first row and subtract 2 times the second row. Rows 2 and 3 are complete. Each of those rows gives us a solution. So I'm going to go ahead and write row 2 and row 3. Now, take equation 1, or take row 1, and take -2 times row 2. -2 times row 2 will give us a -2 here, and a -2 here. Stay. There'll be a 1 and a 0. Something is wrong, probably with my first row. Hold on for a second, let's see what's going haywire here. Okay, I'm apparently making every mistake possible be made here. I did row 1 minus 3 times row 3. I got -3 times row 3 gave me a -3 and a +3. Okay, -3 added to 3 gave me 0. And then I didn't bother adding the 3 2 because that would be given 1. Now when I do row 1 minus 2 times row 2, I get -2 here added to 2 gives me 0. And -2 added to 1 gives me -1. So I apologize for all the mistakes that you see if you need. Maybe write down calculations carefully at every stage. Okay? And usually I don't need to do that, but today, for some reason. Some blinded on that stuff. It's not particularly normal. So again, let me emphasize this, do the calculations carefully. Of course, when I grade the tests, I'll be grading the process as much as the correctness, okay? So if you make little errors like I do, you're going to end up with some nasty fractions, which will motivate you to get the right results. But there it is.